Alright, so now it's time to use simultaneous equations to solve worded problems. So let's go through and actually read the question first and highlight any key information. Solve the following. Two shoppers buy the following at a fruit shop, paying the amounts given. What was the cost of each apple and each banana? So basically the question's asking, what was the cost of each apple and each banana? Alright, and of course shopper 1 buys 4 apples and 3 bananas for $2.59, and shopper 2 buys 6 apples, 5 bananas for $4.11. That there is the key information because it's given us numbers that we can then work with. Alright, first of all, before we do anything, what we need to do is define what we're looking for. Now, what are we looking for? Well, if we read the question, the bit that we've highlighted says, what was the cost of each apple and each banana? So that's what we're actually looking for. So what we're going to do is we're going to assign a pronumeral to each thing. So we're going to say A is equal to the cost of an apple. So that's what we're looking for. And B is the cost of a banana. Alright, so essentially, the pronumerals that we assign will always represent what we're actually looking for. Now we're going to use the information that they've given us here for shopper 1 and shopper 2 to write out a simultaneous equation. And what we're going to do to make life easier is talk about all of this in terms of cents, because when you've got decimal places it just makes it a little bit harder to work with. So we're going to find the cost of an apple in cents and the cost of a banana in cents. Right, so we know that 4 apples, 4A, because that's what we're looking for, plus 3 bananas is equal to $2.59, which in cents is $259. Alright, and we'll call that equation 1 because it's shopper 1. We also know that 6 apples plus 5 bananas is equal to $4.11, so 411 cents, and we'll call that equation 2 because it's shopper 2. Alright, let's have a look. Are we going to use the substitution method or the elimination method? Well, are there any pronumerals without a coefficient out the front? 4A? No. 3B? No. 6A? No. 5B? No. That means we can only use the elimination method. Okay, so what we're going to have a look at here is which pronumeral we want to get rid of first. I'm feeling B, so let's go through and do it. What I'm going to do to get rid of B is I'm going to look for the lowest common multiple between 3 and 5, which is 15. So it means I need to multiply this one by 5 and this one here by 3 in order to get 15 B's. So multiply everything by 5 gets us 20A plus 15B is equal to 259 times 5 is 1295. Multiply all of equation 2 by 3 gets us 18A plus 15B equals 411 times 3 is 1233. And we'll call these equation 3 and equation 4. Now what we're going to do is we're going to subtract equation 4 from equation 3 because the 15b's will cancel out and we want to make sure we try and get positive a's. It just makes life a little bit easier for us. So equation 3 minus equation 4 will get us this. 20a minus 18a will get us 2a and the 15b's will cancel each other out. So we're left with 2a is equal to 1295 minus 1233. That will get us 62. If you don't believe me, once again check it on the calculator. Now we have 2a is equal to 62, so of course I divide both sides by 2, leaving me with a is equal to 31 cents. So according to this, an apple will cost 31 cents. Let's look at how much a banana costs now. So what we're going to do now is we're going to substitute a equals 31 into either equation. Let's just choose equation 1 to make life easy. So a equals 31 into equation 1. Write out equation 1 now, you get 4a plus 3b is equal to 259. Okay, so substituting in 31 now for a, so you get 4 times 31 plus 3b is equal to 259. 4 times 31 will get us 124, plus 3b is equal to 259. Now what we're going to do is subtract the 124 from both sides. So when you go minus 124 and minus 124, you're going to be left with 3b is equal to 135. Divide both sides by 3 now. Ends up with us having b is equal to 45. Therefore the cost of an apple is 31 cents and the cost of a banana is 45 cents. Now you could check this answer using your calculator or once again by substituting both of these values of a, for a and b into both of the equations 1 and 2. And now it's time to press pause once again and attempt the following question. Remember guys, press play once you finish and check your answers against my solutions. Okay, so what you can see here is that I've highlighted all of the key information. The zoologist counts the number of penguins and giraffes. Now why is this important? Well, because we talk about feet later on in two enclosures at the zoo, and notes that there are 57 animals and 196 feet. Okay, obviously there's numbers there, so we need to know what we're dealing with. Assuming no animal amputees, now this is important because we need to know that they're all normal animals. How many of each animal are there? Okay, obviously that's the question that we want to answer at the end. So, I've highlighted all the key information. Now I need to write out that information in algebraic terms. So what I've gone through first of all and done is actually define the things we're looking for. Now of course we're looking for how many of each animal are there. That is, how many penguins and how many giraffes. So P is equal to number of penguins and G is equal to number of giraffes. The next thing that I had to do was go through and come up with two equations that represent what's going on. Now it says that there are 57 animals. That means that the number of penguins plus the number of giraffes is equal to 57. So the number of penguins here, P, plus the number of giraffes, G, is equal to 57. That there is equation 1. Right? The next thing that's important is that there is 196 feet. Now if we think about it, we know that penguins have 2 feet. Alright, if you've seen Happy Feet you'll know that. And the giraffes have 4 feet. So because of this we've got penguins times 2 for number of feet and giraffes times 4 for the number of feet is equal to 196, and we'll call this equation 2. Separate that so we can see. Now what I've seen here is that we've got P plus G is equal to 57. If we have a look, we can use the substitution method because we have both P and G on their own. So what I've done over here is I've rearranged to get P on its own. So that is, I've subtracted G from both sides, making these G's cancel out and getting P is equal to 57 minus G. I'm going to call that equation 3. Alright, I've rewritten out equation 2, and what I'm doing here is I'm putting 3 into 2. Alright, so what we get here is we're putting, instead of writing the P here, we're writing 57 minus G. So you get 2, instead of writing P, 57 minus G, plus 4G, being this part here, equals 196. Expand the brackets, 2 times 57 is 114, 2 times negative G is negative 2G, plus 4G at the end there is equal to 196. Right, the negative 2G and the positive 4G here will simplify to get positive 2G here. So you end up with 114 plus 2G is equal to 196. Next step here is just to get G on its own, so circle that, that's what we're looking for. So we subtract 114 from both sides. These will cancel out, leaving us with just 2G on this side, and 196 minus 114 is equal to 82. Next step here is to get G on its own, is to divide by 2, divide both sides by 2. The 2's will of course cancel out, leaving G on its own, and 82 divided by 2 is 41. Now that we know that we have 41 giraffes, we can substitute this into one of the equations. Now I've chosen here at equation 3 because we are trying to find the number of penguins, and we've already got an equation for that. So we're going to substitute G equals 41 into equation 3. So penguins is equal to 57 minus G is the equation. So instead of writing G, I know that G is equal to 41. So I go penguins is equal to 57 minus 41. 57 minus 41 of course is 16. Therefore we know we have 16 penguins and 41 giraffes. And if you ask me, that's a hell of a lot of giraffes for one zoo, and they could probably share it around.
Alright guys, thank you very much for tuning into today's lesson, which is all about simultaneous equations. Alright, yeah, like I said, today's lesson is all about simultaneous equations. Jerry, what are you trying to do?
You said simultaneous equations. I'm trying to say equations simultaneously with you.
You're an idiot. But let's just do this and get you out of the way so you can leave me to continue on with the rest of the lesson, yeah? So, you ready? 1, 2, equations. Very well done. Alright, get out of here. Alright, so thank you, as I was saying, for tuning into today's lesson. We hope that you learned that the simultaneous equations we use to find the point of intersection between 2 points, and it's not in fact a dual and radial sign. Alright, like always, make sure you stay tuned for the very next lesson because that's all going to be about finding the equation of a straight line. So like always, say hi to your maths teacher for me. Pawsey out.